Till now, what we learned was the basics of Python and different libraries that can be used to implement algorithms and visualize data. There's a lot of them, and I hope you all go through the documentation and look for resources online. We'll share them also. We have a cheat sheet for everything. So we'll put them up on the GitHub repo, and I hope everyone goes through them. That's great. Right. So with the next couple of classes, I plan on going to the basic machine learning terms, how a typical machine learning pipeline looks, and how do you represent data. Harini covered uh, a bit how to represent data using uh, data frames, and then we'll go through different learning paradigms like supervised learning, unsupervised learning, and semi-supervised learning. And in that, we'll look at one algorithm known as k-means clustering. And in the upcoming classes, we'll go through linear regression, mean squared error, gradient descent, and different forms of linear regression. And then we'll go through logistic regression and different classification and regression algorithms as well. So machine learning pipeline is basically how uh, a typical machine learning project looks from end to end. So you start off with some data, you generate data or you collect data. You can have different types of data, like you have tables, as you've seen in data frames, or you can have images, you can have text, speech, dictionaries, and you can either generate data or you can collect data, or if you can scrape data through the web. If anyone has tried this out, might know. Uh, then after getting data, it's important to clean the data in the sense you need to see, you need to maintain how the data is represented. If there are NaN values, or you have to take care of how you represent the data. And then we look at applying algorithms according to how the data is and according to the pattern. And then we finally deploy it. Deployment is mostly a part of web development. You can use Flask and so on. But nevertheless, you can still use Colab to show your visualizations or using matplotlib that you've seen today. So I have a question for all of you. Which one do you think requires the most effort?
In what?
You know, as as a person who's going to make a machine learning pipeline, which one do you think will require more time and more effort? Let's say you have nothing. I just tell you to uh, write up a script to. We'll go through these terms later on, but I'm just saying, write a script to classify data. Maybe you know, make a classifier of dogs and cats. Which one do you think requires the most effort? So Dharmik says data cleaning. Uh, Data cleaning is relatively straightforward, although it is not that straightforward. It is like you can still visualize it, but before visualizing it, what you require is data, right? So that's, according to me, that's what's most daunting task, collecting data. Do you guys agree with me? It's pretty painful to get data, especially if you have all kinds of security reasons. If you've been following the news, what's been happening with Facebook, Google over the past couple of years. Yeah, the options are data generation and collection, then cleaning, applying algorithms, and deployment. Any comments? After that, I think applying algorithms is the next daunting task. Well, we have libraries to apply algorithms and use them as it is. But as I said, imagine you had nothing in your hands, then you would have to write up the entire algorithm by yourself. So I think these two requires the most effort. Anyway, moving on. So the most basic and common type of learning algorithm we'll be seeing is supervised learning. It basically means that you are learning from labeled data. So you run an algorithm through all the training data you have, and the goal over there is to generalize the predictions on future data, future unseen data, so that you have a robust algorithm and it's not biased towards what it's been trained on. And so basically, uh, can you guys see my notebook? Okay. So basically, what you have is you have a data frame like this, and then you have labels. Let's say you're making a cat and dog classifier. Uh, this is known as the X value. So yeah, this is known as the X value, and this is the Y value, which is the label basically. Y can either be dog or a cat, right? And X is basically know, different kinds of features. So you have color, what it is, the dog or the cat, the shape, the tail, and so on. You have different features of the animal, and this will have values in them. Maybe you can say it's brown, or you can say it's a skinny cat, and it has a fat tail, whatever. It's not important. Uh, so anyway, these are the features, and this this is the X train data, X data, and the Y label, and you have to classify whether this given data is either a dog or a cat. So this label can either be discrete or continuous. In this case, we are looking at discrete values. It's either a dog or a cat. Yeah, so based on the outputs, we divide into two categories of algorithms. One is classification. It's a task where the output variable is a category. One such example is whether you're looking at a tumor and you say whether it's benign or malignant. That is, if it's cancerous or non-cancerous. And if you have a continuous uh, distribution, then we'll call it task as regression, where your output, where the output is a continuous outcome, and we have to predict it and generalize the classifier. Any doubts till now? Okay, so I'll move on. So as we've seen, all input data have associated labels. Label can be continuous or discrete. I've taken the example of whether it's an apple or not. Input data are the features, color, size, sweetness, and so on. And every input is associated with some features and labels. And we have to give both the x and y values so that the algorithm really understand what the data is, and it's able to generalize over unseen data. So now we look at how to represent data. Over here I've used the pandas library to see. This is the popular Titanic dataset. You have passenger IDs, whether they've survived or not, their class, name, sex, age. Uh, I don't know what SIBT is anyway. Ticket, fare, and cabin, and where they embarked from. So basically, how this really looks is, so you have the X. By the way, this is the X. If anyone is confused over here, let's say Y is 0 and 1 survived, whether they have survived or not, and the rest can be called as X, if, in case anyone had that confusion. So the X is the data apart from the uh, labels, and you have N features over here. In this case, the features were passenger ID, text, and so on, the name and so on. And this subscript represents, the superscript represents the data point. So let's say there are m examples. It's an m cross n matrix. There are m examples and n features. So this is the first person, let's say, and this is the second person. We can generalize it to. Right, and you can do the same with y. It's got a single column, an m cross 1 matrix. It's y1, y2, y3, where yi can be anything 0 or 1. Any doubts till now? So another example